Hey, welcome to Chemistry with Taylor E. We're going to do a lesson here on how to name ionic bonds. That is a very important lesson. It takes practice to be able to name these correctly, but once you get the hang of it, you're basically unstoppable when it comes to chemistry. So let's go ahead and let's get started. So ionic bonds, all right, are between a metal and a nonmetal. The metal, again, is always listed first, and then the nonmetal is listed second. The metal name, when you go to name these, stays as is. So, for example, we all know sodium chloride, right? Something that we eat every single day, right? We know it as salt, table salt. And sodium chloride, right? Sodium is the name of sodium on the periodic table. Nothing changed about that, okay? So the metal name stays as is. For the nonmetal, you change the ending to end in "ide" with an IDE, right? For example, sodium chloride is a bond, an ionic bond between sodium and chlorine, but I'm not writing chlorine, right? I'm going to write chloride. So drop the ending and change it to "ide." Of course, you know, with chemistry, there are always exceptions, and these are special rules that you really need to make sure that you take into account because you will be using them and needing to know how to differentiate for when these appear. The first one is transition metals, okay? Transition metals, right, that middle section on the periodic table, and even these down here, right, the dark green below the staircase ladder, these are all technically considered to be your transition metals. And again, I call the transition metals the fake people of the periodic table. They act different depending on who they're with. So because of that, we have to represent a Roman numeral to show their charge, okay? Because, for example, iron could be +2, +3, right, +4. It could change its charge depending on who it's with. And so because of that, we have to say when we name it that iron has this specific charge, okay? So very important, make sure you keep those in mind, and you're always checking for that metal and just making sure if it's a transition metal, you take care of it in naming it appropriately with Roman numerals, okay? Except for, all right, there are 3 transition metals that we do not show the Roman numeral for the charge because the charge is always going to be the same. So, for example, silver. Silver is your +1. Silver will always be a +1. So even though silver is in that transition metal area, we do not put a Roman numeral for its charge. Same thing for zinc. Zinc always has a +2 charge, and again, zinc is in that transition metal area. We do not put a 2 for the charge of zinc, okay? You just write zinc. And scandium, okay? So scandium is a +3. I listed these in +1, +2, +3 format, so just something to keep in mind. This is an honors chemistry, maybe college level chemistry exception, but your normal chemistry, standard chemistry teacher might be asking you this, so just keep that in mind, okay? And lastly, this is very, very important, we have our polyatomics. I want to break this down real quick because you're going to be seeing these over and over again, and I'm going to give you some tips and tricks on how to identify them. Poly means many, right? And then atomic is standing for atoms, right? So it's many atoms, okay? And these are things such as sulfate, chlorate, nitrate, nitrite, chlorate, chloride, right? And so when you're looking for those polyatomics, if you notice, they end in ate and ite, okay? I like to reference the song, at least when I was in preschool, early elementary school. There was that song, it was like, I like to ate apples and bananas, right? And then ite. Anyways, I think of those when I think of polyatomics. Most likely, in the high school level, your teacher gives you a polyatomic ion list. This is the one that I give my students in honors chemistry. And so you either need to reference them, right, and just be able to find them. And here's the thing about polyatomics. Again, poly means many, and atomic is atom, so it's many atoms, right? And every element on the periodic table starts with a capital letter, right? So for example, sodium chloride would be NaCl. I have 1, 2 capital letters. That is a normal ionic bond. There's no polyatomic present. But let's say I have ClO3, for example. Okay, I have 1, 2, 3, the oxygen, all right, so 3 capital letters here. That is a guarantee that I have a polyatomic present, and so I need to go find ClO3, unless your teacher's making you memorize them. I need to go find ClO3 on the list and see that it is chlorate, okay? So when I go to name it, I need to say chlorate. I'm not going to say chlorine oxygen. I'm not going to say chloride oxygen, you know, nothing like that, okay? You need to find ClO3, and again, majority of the time it's the non-metal spot of an ionic bond, the anion. The second thing listed here in the ionic bond, go find what it's called and write it appropriately, okay? So polyatomics, keep those in mind, very important, okay, as we continue on. And Roman numerals, by the way, if you don't know your Roman numerals, we'll just go through them real quick. This is 1, right? This is 2. This is 3, right? IV is your 4. and then V is your 5. You may go to 6, but you really won't go past that. So these are your Roman numerals. If you haven't used them before, it's been a while. The only reason I knew my Roman numerals back when I was learning chemistry was because of my history teacher. Our notes were organized by Roman numerals, and so that was my only, exposure to them. So there you go. Quick recap of your Roman numerals and the numbers that they represent, okay? All right, let's practice it, okay? Because that's where you really get good with it. The question's going to ask you some sort, write the name for the following ionic formulas, okay? All of these are ionic formulas. You might be given a worksheet that has a mix of ionic and covalent, so you need to keep that in mind as you continue on. Remember, ionics always start with a metal, and so every single one of these examples starts with a metal, okay? And so if you have a mixed type of worksheet that has ionic and covalent, you need to identify if it's ionic or covalent first. I have a video on that. Then name it appropriately using the rules, okay? So let's go from here. Again, just to recap, the metal name is going to stay as is, and then the non-metal ending, we change it to "ide." We need to keep an eye out for transition metals if they appear, and for polyatomics if they appear, all right? So those are the 4 big things to keep in mind. So let's start. Al, that is aluminum. I'm going to write that as is, aluminum. And then Cl ends in, Cl is chlorine, and so I'm going to change that to chloride. Notice this 3 here. I'm not trying to put it in the name somehow. The 3 is here. Again, this is from making an ionic formula. The 3 is here because aluminum is a +3 charge. Chlorine is a -1 charge, and so that's that drop and swap method to balance the ionic charges there. You don't need to be doing that, but I'm just showing you where that 3 comes from. And notice it doesn't have any relevance in the name, all right? Use the naming rules and stick to it, okay? Don't try to do too much. All right, Ki, all right? K is potassium, so I'm going to write that out. All right, and then I is iodine on the periodic table. I need to change that to iodide, all right? Number 3, I have Ag. Ag is silver. In my mind, I think, ooh, silver's a transition metal. But remember, silver is one of the exceptions, all right? So I'm not going to write silver Roman numeral 1 for the charge. I'm just going to write silver. And then again, Br is bromine, so I'm going to say bromide. All right. Continuing on, we have Al2O3. This is Al standing for aluminum. And then O stands for oxygen, right? Which we change the ending to ide. So ox-ide. All right, good. Continuing on, number 5, we have K3N. K stands for potassium. And N stands for nitrogen, which is nitride. Right, nitride. Okay, awesome. All right, number 6. This is not calling you ugly in Spanish. This is Fe and O. So Fe stands for iron, and in your mind you should be having like a little ding 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 going off. Why? Because iron is right here smack dab in the middle of the transition metals. So that means I have to figure out what the charge is of iron in this specific example. I can't just make it up, right? I can't just go and reference. For example, if you do have a transition metal sheet, I can't just pick 1, 2, or 3, okay? Because the reason is this formula was given to me, so I need to get the charge derived from the formula that they gave me. So here's how we do it. The nonmetal never changes, okay? The charge of the nonmetal is never going to change. Oxygen on the periodic table has a -2 charge, right? If you're looking, if you don't know where that came from, I do have a video, type an ion charge, and I'll explain that, okay? So oxygen has a -2 charge, and Fe, iron, there's only 1 of each of them. So that means iron has to be a +2 charge for those to cancel out, okay? So I'm going to do iron, Roman numeral 2, because that's the charge of iron, and then O is oxygen, which I change to ox-ide, all right? All right, leveling up here, number 7, we've got Ti2S. Ti stands for titanium, and as well, that should be kind of a ding, ding, ding going off in your mind. Titanium is not a normal metal, it is a transition metal. So that means I have to show the charge of titanium in this problem using Roman numerals. So here's how we do this again. Look at the nonmetal. Sulfur has a -2 charge. And so titanium total has to equal +2, but the problem is we have 2 of them. So what can I split +2 equally among 2 titanium atoms to give me +2? +1, right? Because +1 + 1 is +2, and that's going to balance out the -2. So titanium in this example has a +1 charge. So it's titanium 1, sulfur becomes sulfide. Okay? All right, moving along. Number 8, magnesium, MgNO3 2. Okay? You should be seeing something completely different from the rest of these, right? Remember I mentioned all of these so far have had 2 capital letters. How many capital letters are in this one? 1, 2, and 3. Oh, I know a polyatomic is here. So don't, I need to go and figure out, right, from a list, or you need to have it memorized, depending on what your teacher asks of you. You need to figure out the name of NO3 because it has its own name. So I'm going to reference my polyatomic list. NO3 is called nitrate, right? Nitrate. And so I need to name it as nitrate, okay? So let's start from the beginning though. Mg stands for magnesium. And NO3 stands for nitrate, okay? Very important there. You've got the polyatomic and you have that ending. This is the first time we've had an ending that wasn't "-ide", okay? So just be very mindful of that. Every letter matters, okay? If you were to put nitride, that'd be incorrect, completely wrong, okay? This is nitrate. If it was nitride, it would just be Mg3. It would look like this. It would just be a singular nitrogen, okay? This is not a singular nitrogen. This is nitrogen bonded to 3 oxygens, aka nitrate, all right? All right, 2 more here. If you're feeling fancy, if you're feeling up for it, try 9 and 10. Pause the video real quick and attempt them. Okay, here we go. If you're still here, hi, welcome back. Okay, so we have Al. Al stands for aluminum. That is not, the transition metal. Aluminum always has a +3 charge. Your transition metals start like indium, tin, thallium, lead, bismuth. Okay, these down here. And again, you should be given some sort of sheet to reference on the transition metals that do have multiple charges, okay? Aluminum is just a normal, good old metal, okay? All right, so aluminum, and then PO4. Again, I see multiple capital letters there, so I need to find the name of PO4. Right? Obviously, you think phosphorus has something to do with it. So PO4 is phosphate, okay? So I'm going to write aluminum phosphate. Okay, awesome. All right, last one, number 10. We have PbSO32. Pb stands for lead. I always remember that by PB and lead sandwich. It'd kill you, but it gets the point across on what the PB acronym stands for. So Pb is lead, and just to double check and show you, Pb, lead, is in that area where we have to do the Roman numerals, okay, for the transition metal, because lead's charge does change. So I need to be able to figure out what the charge of lead is here in this problem. So to do that, we look at the nonmetal. Oh, but this is not a nonmetal on its own. This is a polyatomic. This is SO3, right? SO3. So I need to figure out what is SO3's charge. SO3 is a 2- charge, so it has a -2 charge. And how many sulfites are there? Right? How many SO3s are there? There are 2, right? You see this SO3 in parentheses? There are 2 SO3s. So that's a total of -2 times 2. That's a total of -4. So what does Pb's charge have to be to balance that out? It has to be a +4, all right? And there's only 1 Pb, so it gets all of that charge to cancel out that compound. So lead, IV, is the Roman numeral for 4, and then SO3 is called sulfite. Awesome. And there you go. All right, you got the ite. That's like the little sibling of sulfate, right? That's how I like to think about it. But there you go. 10 fantastic examples of naming ionic formulas, doing the easy ones, going down to the more complex ones. And there you go. I'll see you guys on the other one. Have a good one. Bye.